it would have distributed amongst the ejecta that was created beneath it. It would also have seen a great variation in the deposits left behind. There would have been intense burning over a large area. Anything within the impact zone, of course, would have been devastating. At the same time, however, it would not have had immediate impact for the rest of the planet, just within the impact area itself.
This so-called Clovis comet theory suggests that profound climate changes led to the eventual extinction of the mammoths from North America. However, contrary to popular belief, a small number actually survived in various regions of the world up until around 2000 BC. And archaeological evidence indicates that the Clovis culture didn't go extinct from this alleged impact. Rather, they adapted to their changing environment.
When the large game animals that Clovis people were hunting disappeared from the landscape, people had to change the way in which they were hunting and gathering.
We may never know with certainty whether a near-Earth comet caused the Clovis event. But would modern man learn to survive after an Earth impact? We may eventually be put to the test. At this very moment, meteorite scientists scour the landscape in search of these messengers from the sky. These space rocks hold clues to impacts of the past, and as scientists are now discovering, clues to what is coming in the future. Mass extinctions, mile-wide craters, scorched landscapes, all created by objects from space. Meteorites have been intruding on our planet since the formation of the solar system. So where do we typically find these rocks?
Most meteorites, they're more easily found in dry desert regions of the Earth, for example, in the Saharan desert or even the cold deserts like Antarctica, where there's not a whole lot of vegetation or there's not a whole lot of other rocks to confuse you. However, meteorites fall everywhere on Earth with equal probability.
Cosmochemist Meenakshi Wadhwa has traveled the world in search of meteorites and now oversees the largest university-based meteorite collection in the world.
We're here looking at the collection of meteorites in the Center for Meteorite Studies at Arizona State University. There's basically 3 different kinds of meteorites. You can have stony meteorites, stony iron, or iron-rich meteorites, but all 3 kinds have at least some amount of metal. And so you can distinguish terrestrial rocks from meteorites by the content of metal in meteorites. The other way to actually distinguish a meteorite from a terrestrial rock is that you'll actually see a fusion crust on meteorites that forms on these objects when they're falling through the Earth's atmosphere.
Most of the meteorites recovered originated in the asteroid belt between Jupiter and Mars. But nearly 4 dozen actually came from our moon and the planet Mars.
The idea there is that you probably had a large asteroidal body that impacted the moon or Mars and ejected pieces of the crust of the moon or Mars. And these ejected pieces probably fell into these unstable Earth-crossing orbits, and eventually pieces made their way to the Earth that way. This is a piece of a lunar meteorite, and we believe it came from the Highlands portion of the moon. And we know that this is actually a lunar meteorite because we can compare this with actual samples that were brought back by the Apollo missions in the late 60s and early 70s.
Meteorites are precious research subjects. Although they've destroyed life time and time again, they may also have provided the chemicals needed for life on Earth.
This is possibly one of the most well-studied meteorites in the world. It fell in 1969 in Mexico. And an interesting thing to note about this rock is that these white grains are possibly some of the oldest solids that formed in our solar system as our solar system was forming 4.5 billion years ago.
These white grains, combined with the atmospheric chemicals and organic compounds on Earth, may have formed a mixture of amino acids, the essential elements of life.
So meteorites have played a very important role in possibly the formation of life on our planet and certainly the evolution of life on our planet.
Meteorites may have once provided the necessary components for living things. But they can be a source of grave concern when they hurtle down from space without prior warning. September 19th, 2007. A fiery meteorite streaked down from the sky and impacted the soft soil near the Peruvian town of Caracas, which borders Bolivia. Debris flew over 600 feet as the meteorite left a crater over 15 yards wide and 15 feet deep.
There was a gentleman riding a bicycle and he was knocked over. Another person looking the other direction quickly turned around and saw this thing hit with a large plume rising above. In talking with the locals, the villagers, they had no idea except they thought maybe this was some form of military action. You know, they're very close to the border of Bolivia.
Scientists reassured the locals that a meteorite, and not a missile, caused the impact crater. But immediately after the event, many villagers complained about headaches and vomiting.
They literally became ill, most likely because of sulfur or because of the fine dust that was inhaled. The vapors probably came from the material that was following the meteorite as it was coming through. It was melting, it was vaporizing as it passed through the atmosphere, and it probably, when it hit, caused some additional release of gas.
But could a space rock actually deliver harmful elements to Earth? Sci-fi movies and conspiracy theorists have proposed that meteorites could seed our planet with lethal bacteria or viruses. But what's fact and what's fiction?
The probability of this happening is very, very, very small. If that rock made it to Earth and somehow that microbial life form survived, it would find our atmosphere very toxic. Any microbe that evolved in an anaerobic, in a non-oxygen environment, is not going to survive long in oxygen.
The possibility that the Peruvian meteorite committed cosmic biological warfare is remote. But had this small stony meteorite impacted a nearby village, the aftermath would have been much different.
This would look like somebody had planted a roadside bomb. It would have had that effect. It opened up a hole so large that it would have swallowed several cars.
The Peruvian meteorite impact once again illustrates the unpredictability of things that fall from the heavens. And space rocks aren't the only objects that can cause bodily harm. Up to 200 heavy objects hit our planet each year. And they're not extraterrestrial, they're man-made.
By GNC.
2 minutes to
February 1st, 2003. The space shuttle Columbia was about to conclude its mission in space when disaster struck. The vehicle disintegrated during re-entry into Earth's atmosphere. Debris fell over Texas, Louisiana, and Arkansas. All 7 crew members perished.
Because of reentry heating, it got hotter as it came into the atmosphere. Some critical components failed. That caused an overall failure of the entire spacecraft, which spread debris over a large footprint.
Spacecraft re-entry disasters are rare, but space debris is not. Since the beginning of the space age, rockets have carried thousands of satellites into orbits around our planet. As a result, we've littered space with spent rocket stages, defunct satellites, fuel tanks, as well as nuts, bolts, and fragments from collisions and explosions with other debris. This abandoned space debris hovers over our planet like a cosmic garbage dump, and some will eventually fall back to the Earth. The question is when and where.
Things that re-enter the atmosphere, they do have a risk. The real risk is that something falling through the atmosphere will hit a person on the ground.
5,400 tons of space junk has already crash-landed on Earth. In 1979, Skylab, the first space station, scattered debris across the Indian Ocean and parts of Australia. In 1997, a DVD-sized piece of smoldering metal fell from the clouds and brushed the shoulder of a woman near Tulsa, Oklahoma. She wasn't injured, but hundreds of miles away, this 570-pound stainless steel tank landed next to a farmer's house in Texas. Both were pieces of debris from the same stage of a Delta II rocket.
It's a piece of debris from a launch stage that was in orbit for about 9 months and re-entered over the northern part of the United States and Canada. Came down and left several fragments of debris around. This was the largest piece.
At the Aerospace Corporation in El Segundo, California, scientists study space debris to find out what materials survive re-entry and why, and how to minimize future hazards.
This is remnants of a stage that put a GPS satellite into orbit. This was found in Saudi Arabia. This one is made out of titanium, which is a very high melting point material, and that's one reason why this one survived so nicely. And this was traveling again on the order of probably 150 miles an hour when it hit the ground.
Why do objects fall back to Earth? Most space debris resides in low Earth orbit, approximately 600 miles above our planet's surface. In space, objects can stay for tens to hundreds of years because there's no air resistance. But they will eventually undergo orbital decay. They will lose energy because there's very little atmospheric drag, and the Earth's gravity will tug them back down into its atmosphere.
Satellites fall back sometimes quickly and sometimes over a long period simply because they begin to touch a little bit of the atmosphere, enough of the atmosphere that there's an increasing force over a long period of time, and that small force acting over a long time will basically drag them out of orbit, and they will eventually re-enter.
Most debris burns up during atmospheric re-entry and vaporizes. However, some pieces are made of stronger components such as stainless steel and titanium, which can survive tremendous heat. Once below the dense regions of the atmosphere, they literally free fall to the ground.
It'll hit at a very low velocity, say 150 feet per second or 150 miles an hour, something like that. And so that's the problem. So you're basically slowing something from an orbital speed down to essentially nothing in a relatively short time.
Main engine start.
The international space community now imposes new design requirements for most objects, including a propellant system to ensure controlled re-entries over water.
Basically, the international community has agreed that an acceptable level of risk for a reentry is around 1 in 10,000. That means that if you did a particular reentry 10,000 times, the likelihood is that you'll hit one person on the planet. And so if you exceed that threshold, the objective is that you should reenter that piece of hardware into a safe area like the ocean.
But new guidelines won't have any effect on the thousands of pieces of old debris already in space.
Unfortunately, we have a number of objects in space still which were not designed when that requirement was around, and they still are slowly coming down. So it'll be a while before some of these things take effect.
It's no longer a sci-fi fantasy. Extraterrestrial and man-made things continue to fall to Earth. We constantly need to search the skies for objects that could decimate a neighborhood, or even worse, end human civilization.